All right, today's notes is going to be on percent yield. So let's talk about percent yield. So really, yield just implies we're talking about how much we can produce of something. So this is our so we're looking at how much we can produce of something. Now, when we look at it in terms of a percentage, this just means that we're ratioing two numbers. So what are the two numbers that we're going to ratio together? Well, this is where we're going to do an actual yield and an actual yield is what happens in real life, kind of in the experiment. When we compare that to, say, a theoretical yield, and this would be our perfect situation. Okay, so perfect situation versus the real life situation. So that's kind of how we compare these two things. Now, when we talk about it in terms of a percentage, so our percent yield is really the ratio of what happens actually to what happens theoretically and then we just times it by 100 to make it into a percent. So this is just a representation or a formula representation of what happens. We generally never see a percent yield be over 100%. And the reason why is that in the real life, we generally have some kind of a loss that might happen. So maybe we lose a little bit of some of the particles in the transfer from one container to another, but there's always going to be an expected loss. Now, we like to be at 100% yield because that means that we're actually capturing everything that we'd expect, but that isn't always the case, and so usually we're never over 100%. So that's kind of our explanation. Let's look at how this ties into like an actual production or a practice situation. So let's say that we're going to make some methanol. So methanol is like, so we're going to produce some methanol, but we have to have our two reactants that we're going to start with. So we're going to start with some carbon monoxide and some hydrogen gas. And we're going to react this to form our methanol. Now, methanol is a hydrocarbon. So there's our methanol that we're going to make. And so we're going to go through a process in generating this by using these two reactants. We first need to balance this, so let's double check to make sure that this is balanced. I see I've got one carbon. I've got one oxygen. I've got 1, 2, 3, 4 hydrogens, so I need a 2 there, so I have my 4 hydrogen. So there's my balanced chemical equation. Now let's say that we're going to start with we'll give 75 grams of our carbon monoxide, and we know that we're going to actual yield 68.4 grams of the methanol. So I'm going to list this. This is the actual yield, because they're going to tell us that number in a problem. So we know how much we're going to actually go. And this is what our reactants is that we're starting with. So we're going to set up a stoichiometry problem to get from this, our methanol, or our carbon monoxide, to this, so we can make a comparison. And what we're really doing is we're finding the theoretical yield. Okay, So we're going to go through and find that theoretical yield. So let's start our stoichiometry. We're going to start with our 75 grams of carbon monoxide. We're going to transfer from grams of CO to moles of CO, and it's a 1 mole, so now this is where I have to look up my carbon. Okay, so my carbon is 12.01, my oxygen is 16.00, so 28.01 would be the molar mass of the carbon monoxide. Now we're going to do a mole to mole transfer. This is a 1, this is a 1, so it's an easy one. It's 1 mole of CO to 1 mole of CH3OH. And then we just need to get our molar mass, so we're going to go 1 mole of CH3OH. So we got to figure out our grams of CH3OH. And let's see, carbon is 12.01, hydrogen is 1.01, but there are 4 of them, and there's the 16 for the oxygen, so 4.04, 5, 0, 10, 12, 32.05. So we're just coming up with our molar mass. Now we just go through and do our calculation. So I'm just going to take my 75.0. We're going to divide that by the 28.01, and then we're going to times that by the 32.05, and that comes up with 85.8 grams of CH3OH. So that's our theoretical yield. So now what we want to do is figure out, well, what is the percent yield of this process? So to find our percent yield, we just have to do the ratio of the two. So percent yield is equal to our actual yield over our theoretical yield, and then we're just going to times that by 100. So back to our calculator here. Oops. We've got our 68.4 divided by our 85.8. We times that by 100. So this is going to be a 79.7% yield. Okay, so that's the way we kind of set up and do that percent yield problem. Let's go through on one more example, and maybe we'll tie it into yesterday's learning on limiting reactant. All right, so here's our reaction. We've got magnesium iodide is going to react with bromine, and iodine is going to be released. Let's walk through this again to kind of see what type of reaction we're dealing with. So this is reacting with, so there's our plus, and bromine is the other reactant. Iodine is a product. Okay, there's got to be another product here. I think this is a single replacement reaction. So let's go ahead and write out this balanced chemical equation. So magnesium is Mg, iodide is an iodine, and that's a -1. So +2 -1, so it's got to be I2. That's going to react with our bromine. Remember, that's one of our diatomics, so we got to have that as Br2. That's going to form our iodine. That's another diatomic. And then we're going to make some magnesium bromide, it looks like. MgBr2. So there's our single replacement reaction. We'll check to balance it. Looks like everything actually balances well, so we're good to go there. we know that we're going to start with 360 grams of the bromine, 560 grams of the magnesium iodide, and the question is going to relate back to the percent yield of the iodine. So what I'm going to do here is I'm going to try to see if I can help myself out in my stoichiometry. I'm going to convert this reactant to the iodine, this reactant to the iodine, and I'm going to use that trick yesterday where I just compare my two and say which one is the smaller of the two. That's the one that's limiting, and then I've also found my theoretical yield at the same time. So I'm going to go through and do my stoichiometry steps for both of my reactants. So I'm going to start with the 560 grams of the MgI2, and we're going to convert our grams of MgI2 to moles of MgI2, and this is where we have to look that up on our periodic table. So magnesium 24.3 and iodine is 126.9. But remember there's two of those, so I'm just going to go through it and do my math here quick. 4.3 plus the 126.9 times 2, so that's a 278.1. Then our ratio here, our mole ratio is the easy one. It's just a 1-to-1. So 1 MgI2 to 1 I2. These are moles. And then the last thing that I need to do is just get my 1 mole of I2 into grams of I2. That again, I is 126.9 times 2, so 253.8. So running my numbers now, I've got my 560 divided by my 278.1 times my 253.8, 511 grams of I2 is what I would produce if my MgI is the limiting reactant. Okay, so now I'm going to check the other reactant. So we're going to start with our 360 grams of Br2. And again, similar process. We're just going to do a grams to moles. So 1 mole, this is where we look up our bromine, 79.9. So that's 159.8. Mole to mole ratio is easy. It's a 1-to-1. So 1 mole of Br2 to 1 mole of I2. And then our last step is just to convert back into our iodine. Mass 253.8. Alright, so now we just take our 360, divide that by 159.8, times that by 253.8, and it looks like we're going to make 572 grams of I2 if Br2 is a limiting reactant. And so when I compare my two, I try to say, well, I can only make the smaller amount, so the MgI2 is the limiting reactant because the smaller quantity is what I can make. So now I can do my percent yield. So the percent yield is, again, my actual yield. So I actually am going to produce 475 grams. In theory, I'm only going to produce 511 grams. We're going to times that by 100 to find our percent yield. So our 475 divided by our 511 times that by 100, I got like 93%. Okay, so again, that's how we can kind of tie this back in, so we can see that we're doing both a limiting reactant problem and a percent yield problem. If you do have any questions as you're working through your activities, make sure you reach out, and have a good day.